Have the relays failed in your linear amplifier? Do you want to fix it without even taking the back off? Then stay tuned and watch this. Recently I've been given a linear amplifier to repair, and it's got a fault where when you go from transmit back to receive, so the PTT's been on, take the PTT off, and the linear's in operate mode, so you've just been generating some RF. As soon as it goes back to receive, you can hear this scratchiness, woolliness on the received audio on the radio. Have a listen to this. And I'm just going to key up and unkey. There you go, hear the roughness when it comes back. There we go. So going to standby. Now it comes back nice and smooth. Operate again. There we go. Sounds rough when it comes back, so I'm going to fix that. Right, that recording is a classic sound of an electrical contact being made again, bringing two bits of metal together, and the contact isn't right. Now, why it starts sort of sounding scratchy for so long, I don't really understand the physics of it, but this can happen a lot. Actually, dry solder joints can sound a bit like that sometimes. Bad connectors in an audio setup, you've got a bit of a dirty jack plug, plug that into the thing and it can sound exactly the same. So what's happening is there's a relay similar to this, it's got some contacts a bit like that in there. This is a plastic housed version of a relay. What it's got, you can see there's a coil, copper coil, lots of turns there, and a couple of pins on the bottom where a voltage is applied to energize that coil, and that creates a magnetic field which magnetizes the bar that's through the center of this coil. This little metal plate there on the top gets pulled down, and when that pulls down, these electrical contacts move backwards and forwards. And this is, it's not a completely sealed relay, so air can get in there, probably a bit of moisture can get in there. General contaminants can over time deposit on the contacts and cause this kind of problem. You could take the relay apart, clean the contacts. You have to do it very carefully, mind you, because the contacts are coated, and if you're too vicious cleaning them, then it can take that coating off, and then it'll just very quickly oxidize again, and you're back to the same problem, or even worse. What I'm going to show you today is how to clean them electrically by flowing a wetting current through the relay and switching it on and off. And you can actually do that in this particular linear amplifier, probably many others, without even taking the back off. Now, the wetting current is the minimum current that should be flowing through the contact all of the time, actually. And this is a common, I suppose it's a design fault, but a lot of the time it's very difficult to get around. But contacts are operated in a dry switching condition, which means there's no current flowing or no voltage across the contacts at all while the contacts are switched on and off. And that saves the wear on the contacts. As the contacts come together and break apart, there's an electrical arc. So on a microscopic scale, the surface of the contacts are actually quite mountainous, and a very small area of the contact touches. And when that happens, it gets very hot, and an arc forms and actually erodes the contact surface and takes the rough spike off. And that's happening all the time as it opens and closes, and if it's switching a current, and that wears the contact out. So it's desirable to not have any current flowing at all when the relay is switching. But it has this side effect where you're not running the relay at the minimum current, the wetting current, and that allows these contaminants to build up on there. So what I'm going to do is feed a current through the amplifier, switch the relay on and off, get some arcs forming on the electrical contacts, and that heat and spatter and everything that's going on the contacts will actually clean it, ready for operation again for years to come. So here's the schematic for the SP Expert 1K, which is what I'm doing the repair on. And this is the input 1 here, in 1, input 2, and the SO2R connector on the rear. And it goes through this relay K5, K2, straight through here. This bit here looks like a frequency detector. Anyway, off we go this way. And we come across K1. Now this is the culprit, I think, in this case. So when it's de-energized, it makes this connection all the way through to out A, which forms the connection to allow the received signal to come straight through. Just zoom out there. And if K1 switches on there, or K1B, they're dual relays these, it actually connects the input through to here into the input of the PA stage, and it goes through these transformers here, through one transformer back out, through the other one back out, through the other one down to ground, and then these MOSFETs here, Q2, Q3, Q4, Q5 and so on, they are the beasts that do the amplification. So my plan is to short the output out to ground, and in the input feed a voltage or a current, I'll come on to in a minute, which will flow through the relay, through the output down to ground. And as we switch this relay on and off, it's going to divert that current through here. Now, unfortunately, we have got a short to ground here as well via all these input transformers. That isn't really going to matter. The amplifier isn't going to pick up any of these signals that we feed through, as long as we limit the amount of current that's flowing to wet the relay, the wetting current, as long as it's, probably less than several amps. I'm going to use about 0.6, 0.7 amps, much higher than the relay wetting current specification. But I really want to get a nice spark there, so that I just have to do a few switches and it will clean all the contacts off nicely. And I am going to use a power supply to limit the amount of current that does that. So anyway, we've got the voltage is going to come in through the relay, through the short that I apply to the output. We switch that relay on and off. It's then going to divert that current either through the amplifier primary or through the short on the output, get some nice sparks either side as we switch that on and off. That's the plan. So I've made myself a shorting plug, a PL259 with a bit of coax in there, which is shorted out on the rear. I've used some connectors I had lying around to connect my bench power supply into input 1 of the linear. I've set my bench power supply to 8 volts and 0.673 amps, that's saying there, doesn't really matter. Apologies for the photo, the shutter speed was a bit quick on the camera. So that is saying 8.00 and 6.7.3 point, because that's how it comes out for some reason. That's the current limit is set by that limit knob there. And what that does is when the power supply gets shorted out, it won't let any more than that current actually flow. So it's 8 volts open circuit, short circuit, you've got 0.673 amps, which is going to flow. So I've now also got my shorting plug into ANT1 to short that out. The power supply is going into the input, and I've got a PTT line into the PTT input of the linear. And with operate off, so it's in standby, and with operate on, I'm going to turn the PTT on and off a few times, and that'll make sure it's cleaning any relays that go through when it's on standby and operate, just to burnish them, to try and prevent any other future problems. And let's now see what the effect of that's been. And now this is after cleaning the relays with the current, and as you can hear, there's no noise now, none of that burbling noise when the contact's made, and sounds as good as new to me. Right, so the only thing that's left for me to say is try this at your own risk. I'm not taking any responsibility for you blowing up your linear amplifier. Look at the schematic, check the schematic, and if you're not sure, don't do it. But I would think it'll probably work with most linear amplifiers. If you don't have a power supply with a current limit that I've used, you can use your shack power supply with a limiting resistor. And depending on what current you want to use as the wetting current, you may need fairly large power resistor. But give it a go, and I hope it saves you having to dismantle your linear and perhaps desoldering and replacing relays and so on, with the risks that are involved in that damaging the PCB. So I hope it's been useful. 7-3, until next time. Thanks very much for watching, and please like and subscribe if you enjoyed the video.